Hello, ladies and gentlemen. Welcome back to Physics 20, Forces Lesson 2, Forces in Nature, Part 2. Part 2 of Part 2. Anyway, Mr. Sutton is dragging a 50-kilogram cement sack across the floor, mu equals 0.21. What's the force of friction? Because there's no way in hell I'm picking that up. I'm dragging it. 50-kilogram cement a 50-kilogram cement sack across the floor. What's the force of friction? Well, the first thing you do is make a list of everything you know. Mass is 50 kilograms. Coefficient of friction is 0.21, so the floor is kind of slippery, but not too bad. Then you draw a picture, like I've done here. Force of gravity, force normal, force of friction, force applied. Now, somebody will get picky going, do you know which way you're dragging it? No. I'm dragging it one way, and friction is opposing it. Anyway, so here, force of friction is mu force normal, which is mu mg. So I'm applying a force, and there's a force of friction opposing me. So that's mu 0.21 times the mass, 50 kilograms, times 9.81 meters per second squared. Now, technically, actually, no, let's just do the math first, and I'll get into the picky bits. So, just want to remind you, this is mu, how slippery. This is force normal, which is equal to an opposite force of gravity, which is force between them. The objects. Now, force of friction works out to be 103 newtons. So as I drag it across the floor, I have to apply at least 103 newtons to get it to move. All right? So if I apply less than 103 newtons, it's not moving. If I apply 103 newtons, it should just start moving. And think about it. If I apply 104, what's my net force? 1 newton. And then we have mass. We can talk about acceleration, v initial, v final, displacement, time questions. We'll do those later. But let's work up to that. So, a 12-kilogram piece of wood is placed on top of another piece of wood. There's 35 newtons of maximum static friction measured between them. Determine the coefficient of static friction between the two pieces of wood. All right? So here we go. Force gravity. Force normal. Now, notice I haven't applied the force yet. Okay? So I will in a minute, and if you want to get picky, that's a crappy picture. Here's the two pieces of wood, and here's Mr. Sutton applying the force. Okay? Now, determine the coefficient of static friction. So, force of friction, mu force normal, is mu mg. So normally, force of friction is 35 newtons. So I apply 35 newtons and it just starts to move. So the force of friction, the maximum force, 35 newtons, mu times mg. Now the mass is 12 kilograms. Acceleration due to gravity is 9.81 meters per second squared. Now, somebody always says, but Mr. Sutton, shouldn't that be negative 9.81? Yes. But which way is gravity going? Down. Which way is the normal force going? Up, opposite, so it's plus 9.81 in this instance. I don't care. Sorry, the plus and the minus give us directions. The normal force is going up, so it's positive. Right? Now, that's 35 newtons equals mu times 12 times 9.81. I got 117.7. All right? So how do I get rid of times 117.7? Divide both sides by 117.7. So mu, the coefficient of friction, is 0.297. Notice it has no units, but that's moderately slippery. Maybe the wood is wet, I don't know. Actually, no. Wood on wood is something like 0.3, 0.42. Now, static, just start pushing, so 0.42 would be the maximum. But I'm also going up here, wood on wood. Once again, static, depends on who's measuring it, 0.25 to 5, so 0.297 is reasonable. Fairly slippery. Not real slippery, but fairly slippery. Okay? Now, I have a steel box, toolbox, mass 10 kilograms, sitting on a steel workbench. I tried to push the box out of the way. So, draw a free body diagram of the box. Well, here's the box. Force applied. There will be a force of friction opposing that. Please do not forget force gravity, which is always there, and force normal, which is always there. Now, this is normally about the point where I start putting numbers in because I know there's going to be a question. Force of gravity, mg, mg, mu mg. All right, now mass times gravity, 10 kilograms times 9.81 meters per second squared, so that's 98.1 newtons down. This is going to be the equal and opposite, 98.1 newtons up, plus 98 newtons. And this is going to be mu times 98 newtons, whatever that is. Now, so far so good? So, I push against the box with a force of 25 newtons. Determine if anything will happen. Well, force applied equals 25 newtons. Force of friction. Now, force of friction is mu. Force normal, which is, force of friction, which is mu mg. Now, I just said steel on steel, and I didn't give you the value. So let's look at the formula sheet here. And steel on steel, right here. Static, that is not moving, mu is 0.74, which means it's fairly slippery. Now, it's going to say down here, steel on steel. Okay. It's also 0.74 down here for static. So 0.74 is a good number to use. So that means it's not very slippery, or there's a lot of roughness there. 0.74 times mg, which is 98.1 newtons. So the amount of friction, or force of friction, is 72.6 newtons, which is less than the force applied, 25 newtons. So what's going to happen? The maximum force of friction is 72.6 newtons, which is less than force applied, which means nothing's going to happen. Nothing happens. All right? I got to put more oomph into it. So what happens if I push with a force of 73 newtons? Well, force of friction is 72.6 newtons, which is less than force applied in this instance, which is 73 newtons. So it just, and I mean just, starts to move. Okay. Now, it just starts to move. Okay? Now I'm going to pause there. I want you to look at this carefully, then I'm going to come back and I'm going to show you the nasty trick question. Okay? So take a good look at this. If you're having problems, watch the video again. Otherwise, good luck. I'll see you in the next video.